All right, welcome to class 4. In this class, we'll go over benchmarking and load factor analysis. Okay, so benchmarking. We'll go over what benchmarking is and how it relates to the utility bill analysis that you're completing, and then also how load factor figures into all this. Okay, so first, benchmarking. So benchmarking is a standard way to compare two practices by using one or more metrics. That's just a generic definition. You can benchmark anything against anything else. You basically need a way to compare two things or more than two things, and you compare them. You can look at, like miles per gallon for a car. That's considered a benchmark, right? So you can compare the MPG for one to the MPG of the other. That's a general what a benchmarking is. So I want you to think about how you can compare the energy use or general energy efficiency of two different buildings using benchmarking. Like, what metric would we use? What would we, how would we determine the basic efficiency of the building, and including the schools that you're analyzing this semester. And this is a review from Energy 101, but feel free to press pause and think about the two metrics that we've used. One, but we'll use two of them to some extent. Okay, so our main two metrics are Eui and Eci. Eui, or energy use intensity, energy use index, is the total energy use over the course of 1 year divided by the conditioned area of the building in square feet. Energy cost intensity is all of the utility costs, all the energy utility costs throughout 1 year, divide that by the conditioned area of the building. Okay, so these are pretty straightforward, and I'll go over an example of this in a minute. But as long as you have the energy use and energy cost for 1 year, and you have the square footage, you can calculate Eui and Eci. So obviously you've already started to go through your utility bills, and you have all the information there that you need. In terms of the units, Eui is usually measured in thousands of BTUs per square foot, or kBTU per square foot, although you will sometimes see just BTU per square foot out there. Eci is I've never seen it measured in anything but dollars per square feet. Okay, so you're going to calculate both of these using utility bills, right? So now that you have all your utility bills, you can calculate the total energy use over the course of 1 year. And you take all different energy sources, convert that to BTUs, and divide that by the square footage. And then you do the same with cost. Okay, so you're going to do that for each year of your utility bills, and then actually calculate the average over 3 years. Okay, so let's go over an example here. So we have a building here that has 25,000 square feet of conditioned space, 2,000 square feet of unconditioned attic space. So we perform the utility analysis, and then we find the following over the course of 1 year. So we'll do 1 year Eui and Eci here. So we have 200,000 kilowatt hours for the year. We pay 10 cents a kilowatt hour. That's marginal. And then 20,000 CCFs of natural gas, paying $1 per CCF. And then our average is 50 kilowatt. Our average demand each month is 50 kilowatts, and we pay $5 per kilowatt per month. Okay, so let's do the Eui first. So what is the Eui in thousands of BTUs per square feet? All right, so feel free to press pause and work through the calculation, but it's pretty straightforward. This is Energy 101 stuff here, folks. So Eui, remember, is the total energy use for 1 year divided by the conditioned area of the building. So remember, we're going through energy use, which is, in this case, kilowatt hours and CCFs. The 50 kilowatts, that's our demand, so that doesn't count. Okay, so this is basic stuff. You're just converting kilowatt hours and CCFs to BTUs, right? So our conversion factor, 3412, 1,100, 2,500 per CCF, and combined, that's about 2,732.4 MMBTU, or 2,732.4 million BTUs. Okay, so that's our energy use for the year. Divide that by the square footage, and we get 109,296 BTUs per square foot. Pretty straightforward math. And then we need, remember, we're asking for kilo BTUs, or thousands of BTUs per square foot, so we just need to divide this by 1,000, and we end up with 109.3 kBTU per square foot. That is your Eui. Okay, pretty straightforward. So any different, whatever energy they're using in the building, you just convert all that to BTUs and divide by the square footage. Okay, so let's do the Eci. Eci, pretty straightforward. How much are they paying for that energy throughout the course of the year, and divide that by the square footage. So remember, this is energy only, so we do not count the demand. That does not count. Okay, Eci does only energy use. right? So it's energy. So it's 200,000 kilowatt hours, 10 cents a kilowatt hour, 20,000 CCFs, $1 per CCF. The total cost is $40,000 per year. Divide that by 25,000 square feet, and we get $1.60 per square foot. That's it. Okay, pretty straightforward. All right, so EUI and ECI, you're going to calculate both of these manually for your building using your utility bills and then the square footage information, which is also provided to you. Okay, so when we're benchmarking, what we're doing is we're taking those metrics, EUI and ECI, again, usually EUI is the main one here, and we compare it to similar buildings in similar climate zones of similar sizes. And it's important that when we're comparing the general efficiency of a building, or the general sort of energy use per square foot of a building, that we're comparing similar building types. If you have something like a hospital, right? So here's Christiana Hospital on the left, top left, versus say Delaware Tech on the bottom right. This is Stanton campus. So Christiana, 24/7, lots of lights, lots of equipment, lots of space conditioning. They have to, sanitization. There's all kinds of things that are using a whole bunch of energy, and they're 24/7, right? There's always energy being used in a hospital. Whereas a college campus, it mostly shuts down overnight. There's a few egress lights, and of course it's heated and cooled a little bit, but it's not in operation. It's not occupied 24/7 like a hospital. So it's not fair to compare the energy use of a school to a hospital. Okay, and same goes for any type of building use. So we want to compare sort of apples to apples as much as possible, which starts with comparing buildings of similar uses. We also want to consider where the building is located, so the climate zone. If you have, say, if I have a Best Buy store that is in Virginia and I have the exact same store in northern Minnesota or southern Florida, Virginia is a very mild climate. Generally speaking, it's going to be a little less energy use than it would be, especially in northern Minnesota. Right? So we're going to compare similar climate zones as well. And then with the different sizes, that's why we divide by square feet. Right? So we take the total energy use, take the total energy cost, divide it by square foot. And if you think about that mathematically, what that means is if we have, let's say we're analyzing a college campus, right? And we have one that's 200,000 square feet and one that's 100,000 square feet. The one that's 200,000 square feet, if it's an identical campus, just half the size, it should use about half the energy, right? So if we divide by square footage, that will all even out. Okay, so that's why we normalize by square feet. Okay, so again, we have EUI, which is total energy use divided by square footage, and then ECI is total energy cost divided by square footage, right? And here's just some sample EUIs of different types of buildings to show you some justification for why you should compare buildings of similar types. So if we have a hospital, it's like 283 kBtu per square foot on average, where education is 85, right? So it's just not fair to compare these across different categories. So if we're analyzing a hospital, we should compare it to other hospitals. If we're analyzing a church or other religious building, we should analyze it to other religious buildings. Okay, so and so you're going to sort of compare buildings in a couple different ways. One thing you're going to do is use what's called the Buildings Performance Database. I'm providing a second video that explains how to use BPD, but I'll briefly explain what the Buildings Performance Database is here. So the Building Performance Database, it's from the Lawrence Berkeley National Lab, which is one of the U.S. national labs. So like NREL is the National Renewable Energy Lab. So Berkeley's a national lab, really good, valid information. It's paid for by federal tax dollars, so all of the information is freely available to anybody. And so what the BPD is it's a database of different building types across the United States, right? So people enter in their data into this database, and it's basically just a compilation of all these different buildings. And so what you can do with this is you can enter your own data, okay? So enter in your own utility use or your own EUI, or determine your own EUI, and then compare it to similar buildings in the U.S. And again, there's a full separate video on how to do this. But the purpose of this is you determine your EUI or ECI, and then you can go in and compare that to the sort of what other buildings in a similar climate zone of similar building types are using. Okay, and so what one thing they give you is this readout of a histogram of different buildings that fit your category across the U.S. And again, I go over this in more detail in this other video. But what this is showing is that the median EUI of whatever set of buildings this is 73 kBtu per square foot. Okay, so if my building had, say, 120 kBtu per square foot, I would know that I am using more energy than the average building. If I'm using, say, 50 kBtu per square foot, I know I'm using less than the sort of typical building. So that's what this is used for, and this is used all the time on energy audits in particular, but also in some solar analyses. Okay, so you'll see a full video on that as well. So that's how you can sort of start comparing your building to other buildings, but there's a more formal way to do this called benchmarking. And benchmarking is something, again, this is a review from Energy 101, but benchmarking is comparing your building with other buildings of similar types in similar climate zone. The main way we do this is through what's called Portfolio Manager, which is from the U.S. Environmental Protection Agency. Okay, again, this is publicly funded, so this is publicly available, and you will enter in your information into Portfolio Manager for your school. And so what this does is it's very similar to the building's performance database, except it gives you what's called an energy score. Okay, so an energy score tells you very specifically where you rank, so to speak, relative to other buildings. So you use Portfolio Manager, you enter in all your utility information, and you enter in your square footage, the type of building, the climate zone, and so forth, and you'll get to practice all of this for your task too. And then what you put in all the information, it actually gives you this feedback. It gives you another metric called the energy score. Okay, so an energy score tells you where you compare to other buildings. Portfolio Manager automatically compares your building to other buildings. So how does it work? If you get a score of 50, that means you are more efficient than 50% of comparable buildings. But it also means you're less efficient than 50%, right? You're right in the middle. If you get a score of 75, that means you're more efficient than 75% of the buildings, or in other words, you have a lower EUI than 75% of the buildings in your category. If you happen to get, say, a 25, that means you're only more efficient than 25% of the buildings, right? So you're in the bottom quartile there. So this is a really nice way to say, okay, here's all my utility usage, here's my square footage, et cetera, and Portfolio Manager just takes care of all of the legwork for you, and it says, okay, you're better than 80% of the buildings or 20% of the buildings, whatever. And there's certain you can get an Energy Star certification if you're at a 75 or above. So one of the beauties of this Portfolio Manager is, again, this is sort of this open source, like everybody enters their data in, and as more people enter the building data in, the benchmarks kind of change over time, right? So if you think about it, if I have, let's say I enter in all my utility information, I got a 75, right? So then next year, if I just don't do anything, I don't increase my efficiency, reduce my energy use, etc. So if I stay on pat, right? So I have my same EUI next year, but everybody else enters their data and their EUI is lower, right? So I was here originally, I was at 75, and then everybody else got more efficient, right? So this is all relative, right? So if I'm here and then everyone else got more efficient, that's actually going to drop my score. So if I was more efficient than 75% of buildings, and then everybody else, or on average everyone else, gets more efficient, my score is going to drop, right? So this is iterative, and it's relative, and it sort of motivates you to keep improving your energy efficiency as everybody else does. Okay, so that's how Portfolio Manager works, and you are going to use this for task 2, right? So this is an industry standard. You will see this in a lot of reports, and as I said, you can earn Energy Star rating for this. Okay, so sort of cover the basics in class, but I'm expecting you to sort of figure out how to do this. Of course, I'm happy to help, but there's a lot of resources out there to help you go through Portfolio Manager. A bunch of tutorials. So EPA Portfolio Manager has a bunch of information online. Okay, and a little word to the wise here. If you may be asked to enter in some information that you're just not sure of. Use your best guess. Just be able to justify it. Okay, and this will pop up as you start entering your information. You can always ask, and you can always sort of stick to the defaults as well. Okay, so we will end that discussion there, and then I'll pick up with load factor in the next lecture.